All right, this is a demo where basically I'm going to run through the alert tuning runbook that I've been working on. This is part of an epic for this quarter where we're trying to improve our notifications for engineer on call for GitLab.com. And one of those improvements is to encourage engineers on call to be able to tune notifications when they see something that is a false notification. So most notifications that anyone receives while on call should point to a critical problem that needs immediate attention in order to prevent or stop an outage or degradation. And ideally, our notification system is going to draw the attention of the EOC to all problems and not miss any. But there's clearly situations where a notification does not indicate an immediate problem. And if you've been on call before for GitLab.com production, you've probably been paged by something where you couldn't identify a true problem that needed intervention or a fix, and you might have been paged by something that when you investigated, you found out wasn't really a problem or didn't require the engineer on call to spend time on it. And in those cases, what we should be doing is trying to tune these notifications to minimize that and increase our signal to noise ratio so that when we do get a page, we feel reliably confident that this is something that the engineer on call needs to focus on right now. Most of our services are measured in a similar method, and the two main measurements that we make are transaction latency and transaction success. There are other measurements like traffic cessation and saturation as well. The general principles of how we make these and notify the engineer on call are very similar between each service. And I highly recommend reading through the metrics catalog README to get a good understanding of how a service in the metrics catalog is laid out and defined, because here is where most of the time changes will be made to tune notifications. And there are several levers, if you will, that we can use to readjust to fine tune these notifications. And I'm just going to step through each of them and show an example of each one as to how it might get changed. And you can see here, I have the runbook up with all this information in it. And the first one we're going to start out with is severity. Basically, without monitoring how our alerts get routed, by default, anything that's a severity 1 or 2 will page the engineer on call. Anything that is lower than that is just going to result in a Slack notification in the production channel. And this can be a good way to alter a notification that maybe we don't want to completely hide it. We still want to be aware of it or raise some attention, but it doesn't need immediate attention, and it doesn't need the engineer on call to stop what they're doing and possibly fix it. And I'll use this as an example. Here's a case where we adjusted the severity of delayed WALI segments on the archive replica. This is something that would be good to fix, but doesn't probably would not have any impact on production. And here we can see that basically the value of the severity was altered. If we look in the metrics catalog, this doesn't have that example. Let's go take a look at So here's a case with the Sentry service where we added a severity S3 as a string. And we can see here then that the auto-generated rules get updated from an S2 to an S3. And what this means is that instead of getting a synchronous notification via PagerDuty, now this will just appear in the production channel and not page. Another example here is selectors. So in our metrics catalog, there are selectors defined for the metrics that we're using for each service level indicator. And these selectors can be modified to more accurately report what we think is a problem or what we want to measure. Here's a case, this MR, where you can see that we have a selector that includes a none of, and we've added the unavailable. I believe this is a gRPC code where we say for the Gitly service, we don't want to include these in our rate metrics. This is a good way where if we have a problematic GPRC method that is okay if it is slow or errors, we could exclude it so that it doesn't cause the EOC to get paged for something that we think is an acceptable activity that should not represent a problem that needs to be corrected. Selectors can have things added, removed. Basically, you're going to be picking what key value labels in our queries we're using to define whether or not something should be alerting or not for Alert Manager. Thresholds are next. When we calculate our Aptx, we basically have a value where we want to see how long a transaction or request takes to fulfill. And we define these thresholds. Typically, we define a satisfied threshold. Here we have an =1. So in this case, we'd say if a transaction takes less than a second, this is satisfied. This is as performant as we want it to be. And then we have another one, we have a tolerated threshold. And here in this example, it's given as 10. Anything that falls between the 1 and the 10, this is designed to allow spikes above the 1 for brief bursts, because we know that sometimes different requests take different time to perform, and during high activity times, there might be bursts of latency. This allows these. There is a good document, Aptx alerts troubleshooting, and there's some other documents in the monitoring section of the runbooks that go into how this is actually calculated. Here's a case where we changed this threshold, and we didn't modify the tolerated here, but what we did was we felt like the image scalar transactions 0.4 was just too small of a window to allow for these, that they were taking longer for normal day-to-day operation. So this was doubled from 0.2 to 0.4. And this allows those transactions to have the time they need to complete without generating a page or a drop in Aptx. So these things, the severity selectors and thresholds, are typically can be set, I believe, per SLI. And the next two, Aptx score and error ratio, these are more service level than SLI level. And changing these is, I put them lower here because ideally we would like to use the first three to make minor changes before we ultimately have to change the Aptx or the error ratio. We do have some examples here where we've changed the Aptx. For example, here we've made some monitoring SLI changes, and specifically, we've defined monitoring thresholds like a 0.92 is probably different than what our global setting might be for this service. In this case, we're basically going to say if our Aptx drops to 92%, that's okay, but below that, we'll consider that crossing our threshold, and one of our SLO alerts will probably page on that. Lowering this is an option, but this also means that if there is something that's making things slow for users of GitLab.com, we may not notice it if the threshold is too low. And then here's a case recently with Camo Proxy where we retuned the error ratio. Now, Camo Proxy is kind of an unusual service in that it can generate a lot of errors even though there's nothing wrong. We would like to know if it's not performing or if there is a real problem, but in this case, the error ratio was changed from a 99% successful completion to 80% is perfectly acceptable for us and generates a lot less noise. And there was research done, obviously, as part of this to try to understand what changing this threshold would mean for pages. And in this case with Camo Proxy, changing the error ratio was considered kind of the right way to address this problem. All right, so those are the big main things. There are obviously lots of other things that could be tweaked inside our monitoring, and this doesn't even get into custom alert notifications such as black box alerts, etc. I'm also going to point out that sometimes removing an alert is a perfectly acceptable way to fix the problem. In this situation, this MR right here, we had traffic cessation metrics, but a service, in this case, prefect replication, how it actually worked changed over time, and it became a lot more indeterminate, and it wasn't a consistent state of traffic. And so what was decided was that because of the nature of the service, the pattern changed, replication cessation metrics were not relevant anymore. And so in this case, we set traffic cessation alert config to false, and it was completely removed so that we don't get notified on that at all anymore, because it's just not, the traffic starts and stops on its own at what seems to be a random intervals based on prefect changes. I will point out there are some other good documents here about an impatient SRE's guide to deleting artifacts. This is a good read and walks you through steps as to how to understand and take action on notifications to weed out ones that we don't need. And there's another one that was written last year, Aptx alert troubleshooting. This goes into some of the math. It also goes into how SLOs are working and how to come up with a good process to triage and troubleshoot those issues. And that is all I have. Thank you.